And you know what that means. That means it's time for COMP1511. Are we excited? Yeah. Well, too bad we're delayed slightly because I invited someone to come to talk to you about video games. That sounds exciting. Less exciting than 1511, so I've asked him to keep it very brief.
Yes. Thank you, Henry. All right. Who here has played like cool math games before? Has anyone played cool math games?
I have.
Who finds it fun? Who likes cool math games? Yeah? All right. And sometimes they're down. Who doesn't like cool math games?
I like it.
Okay. Who would like to learn how to hack cool math games? So like get infinite money, increase your life, stuff like that. Who thinks that'd be fun?
Yeah.
Any hands up? Okay. So if you would like to learn how to hack cool math games, I am running a workshop. It's after the lecture, so it's 1:30 to 3:30. You can get there anytime. It's in K17. So you didn't know this is J17. The building next door is K17. You go upper level. It's in the 7113 room. It's going to be a lot of fun. And there's going to be free pizza. Who likes pizza? Pizza! Alright, so I'll see you there. You can scan the QR code to see more about it. But today, 1:30 to 3:30, we're going to be hacking Fireboy Water Girl. We're going to hack some idle games. We're going to also do some game cheats for like shooters and stuff like that. So it'll be really fun. Come along. See you there. Thanks, Henry.
I already have a microphone.
Oh, sorry.
That's okay. All right, so I like free pizza. I might go learn how to hack some cool math games, but also I might not. But thank you very much for coming and showing us all about that. See you there, maybe. It's right after this. I'm just going to repeat everything he just said. It's right after this. It's upstairs in K17, one of the rooms. If you follow the smell of pizza, which will be quite difficult for the people online, but if you do follow the smell of pizza, you might find it. Right, welcome to the third lecture of COMP1511. And things are going to get trickier, but more fun. I think the programming we've done so far has been a lot of just making statements. We've said X is 42. We've said Y is 12. And then we've printed it. We've said, hey, can you input a number for me? And then they've done it. And we've said, all right, cool, thanks for that number. But now we're going to start doing things with the information that we are provided. We're going to start asking questions. We're going to start repeating things. Our code is going to start to have some structure to it. And in the vein of asking questions, could you throw a chocolate at me? But don't, I'm not trying to repeat last week. Pretend I caught that. I caught it, believe me. If you ask good questions, there will be more chocolates to be thrown at you. And specifically, these ones are the party variant, because this is a party, and we're all going to have a good time. I don't know what a party tastes like. I've not been invited to one, but I heard a lot of sort of sad noises there. That's the correct response. But we'll have a good time. This will be my party. So last week, there was a welcome and introduction, not to Sasha. You'll have to have that later. We started looking at C. We wrote our first program. It said hello to the entire world. We compiled and we ran our code. So not only can we write code, but we can then execute it. We can print things to put things out to get our output on the terminal. And we can scanf things to get things in from the terminal. And also we can do our variables. We've got our ints, our doubles, our chars or cars. I call them cars. And we did some maths. Now, anyone who was in the live stream on Tuesday may have noticed that the internet that I pay $100 a month for died 90 minutes into the live stream. I'm not still upset about it. But that does mean we didn't fully cover maths. But who here knows addition? Yeah. All right, cool. We're probably fine. It's addition, subtraction, multiplication, division. The only one that you may not be aware of is what is referred to as modulo arithmetic. Have people here come across modulo arithmetic before? It's also sometimes referred to as clock division, because you'll see why shortly. Let's go number equals 15. And now I'm going to go new number equals 15. And then modulo is this percentage sign. So I'm going to do a percentage sign, and I'm going to say 3. And now I'm going to printf. How do I, printf percentage d new number. Now I've forgotten some stuff here. Does anyone know what I've forgotten? A whole lot of semicolons, because I actually program in Python most of the time. Oh, that's not where that goes. Oh, it's all falling apart. Luckily, C is actually not an indentation-based language. Unluckily, I am who I am as a person, and therefore do care about my indentation looking nice. Right, we're gonna, no, not Clang, that's a different course. DCC if.c minus O prog. I'm not in my directory. I need to cd into my directory. No, let me just cd into COMP1511, cd into week 2. You can be hidden. Oh, recursion. Let's clear that. List it up. I do now have if.c, so I'm going to dcc if.c minus O prog. I have an error. Unused variable number. That makes sense because I put my, I made my variable. I said it's called number, and then proceeded to not use it. Now, the reason that we have variables is that if we want to make changes later in the code, we don't need to go hunting for them. So actually, let me put number here. And if I wanted to change number later, let's say I used number all throughout my program. It was in lots of different places because it really meant a lot to me. And then my values as a person changed, and I had to update number to be something else. Would it be better to hunt through the code for every single instance of the number 15, figure out whether or not it's the instance of the number 15 that I'm thinking of, and change them to my new number? Or do we think it's better to have one variable up the top that declares my number, and then when I change it, the changes cascade through my program? Who thinks that the second option is better? Who thinks that I'm being facetious and this question is not really worth asking? Well, that's good to hear. One fair enough. Right, now, quickly talk to your neighbor what you think the output is going to be. Very quickly. Quick chat. All right, that's enough chatting. I got jealous of the socializing. Pay attention to me again. Lock back in. I'm going to run it now. Okay, so the way modulo arithmetic works is that you divide the first number by the second number, and then you get the remainder. So if I divide 15 by 3, my remainder is 0. What am I going to get if I divide 15 by 4? What's the remainder going to be? Heard someone say 3. Let's compile it and find out. It is 3. So modulo arithmetic is you take the number, divide it by the second number, and you get the remainder. Right, that's the bit that we missed at the end of last lecture. And we also missed a Kahoot. But if things go well, I do have a Kahoot planned. Try to maintain your excitement. Right, today we're going to talk about if statements and how we can ask questions to our program, logical operations, how we can ask multiple questions with if and else statements. And we're also going to loop and loop and loop and loop and loop and loop and loop with a while loop. I might get stuck there forever. If you want to see the live lecture code, it can be found here. That's what that slide means. All right, refresher on input-output. Let's go over what we learned last week. Okay, to go over what we're doing last week, I guess is up to me. So let's say that actually maybe I'm not going to decide what number is. Maybe actually I want to get my number from the user. What can I do to get an input from the user? What function can I use? scanf. But how do I, I don't know what to write. I'm scared. What do I do? So I'm going to want a print statement up the top. Yep, I want a print statement up the top that will say something like, what is your number? Because we write code for humans, and humans generally need some instructions. So I'll say, what is your favorite number? Did I misspell favorite? That's true. And now how can I scanf the result into a variable? So the first thing I need to do is specify what I'm scanning in. What am I scanning in? Is it an integer, a double, a character? Integer. So what's the operator, what's the format for that? %d. And then how do I tell it where to go? I'm going to go, I believe, ampersand number. That's for memory shenanigans, and we will learn about memory shenanigans later on in the course when I'm not here. So let's try compiling. I have an error because I called my program print. I'm really Python-brained today. I'm so sorry, but that's okay. Printf. If you notice that I do something wrong, oh wow. Start throwing chocolates for people correcting me because I need it. I need it so bad. Have I done something else wrong? There's no \n. Do I want a \n? I'm not sure. Let's find out. I'm going to regret saying this. What's your favorite number?
67.
Yeah. Yeah. All right. Fine. Whatever. And 67 mod 4 gives us 3. So that's getting input from the user. That's putting the output on the screen. The reason we didn't need the \n in the scanf is that in order to do the input, they press enter, which gives us the new line. And so we don't need to specify it in the scanf. All right. Are there any questions about scanf or printf or anything I've talked about so far? If there are, you'll have things thrown at you, but like in a positive way. Reminder being that I can't see, so I'm hoping that they can. Looks like we're good. Looks like, oh yeah, one up there.
So sorry, just 3 questions. Just wondering, what if the user doesn't put in the type of variable you're expecting? If you send it to me an integer.
It's a great question. What happens if the user doesn't do what I'm expecting? Because generally, users are people, and people suck. So let me compile my program. I didn't need to recompile it. Let me run it. My favorite number is actually the letter H. And it's not worked. All right, the program crashes. We should really hope that our user does what we want. Now, I suspected that to load in the ASCII value of H. I'm going to ask this one to my admin team. Why did that not load in the ASCII value of H? Do you know?
Sorry, I was looking at the chat.
OK, I can do it a second time. I'm asking what's my favorite number. I'm going to say the letter H. And now there's a runtime error, because it expects a number to put into number, but it gets a character instead. I thought it would get the ASCII value of H. Is C not smart enough to do that?
I think you can put numbers in characters, but you can't put characters in numbers.
OK,
Yeah, it's like
nice.
It doesn't read the literal value of the characters. It only knows to read the digits when you put in the decimal format.
OK, it doesn't know the number value of characters. It only knows it when we convert it to the decimal format.
Yes.
Very good. And great question as well. Also, give chocolate to someone answering questions for me. Right, now it's time to ask our computers to make decisions. Because sometimes we want to make decisions. Who here likes making decisions? Anyone? Notably, no one. But computers do need to make decisions based on what we know at the time. and we can let our program branch between sets of different instructions. In C, we call this an if statement. Now, the thing about if statements is that someone asks me a question, and I'll answer it like C.
What's your favorite food?
True. What is my favorite food? Yes. Ask me another question.
6 or 7?
6 or 7? No. Someone ask me another question.
Are you wearing a green shirt?
Am I wearing a green shirt? Yes. Another question?
Do you have a life?
Do I have a life? No. Any more questions? Python or C? Yes. Do we, hopefully you understand the point that I'm trying to make. Do we understand the point I'm trying to make here?
Yeah.
Okay, the point I'm trying to make here is that you have to ask yes or no questions to C. If I said to C, what should I get for lunch? It will say true or yes. This is when we use if statements to figure out what to do when the answer to a question is yes or the answer to a question is no. So we can ask things like, is a number even? Is a number larger than 10? Does Henry have a life, if we could encode that into C? These are all questions that we can ask because the answer comes out as either yes or no. Now, notably, how many options are there out of yes and no? 2. There are 2 options. So this actually goes all the way back to the fact that computers operate on a binary system. Things are either on or off, 1 or 0, yes or no. So we'll ask a question, that's known as a condition, and if the answer is yes, we will run some code. That's the general statement of how an if statement works. Ask a question, if the answer is yes, run some code. If the answer is no, don't run some code. Let's do an if statement and see what we can do. So I'm going to keep asking what their favorite number is, but now I want to check if they've picked the correct number. So I'm going to go if number. The way that there's a lot of different symbols that we'll use, and we'll go through all of these symbols shortly. In C, the check to see if something is equal to something else is not just one equals sign. It's 2 of them. So by using 2 equal signs, because what does 1 equals sign do? It does assignment. 1 equals sign, when we have variables, says you my value, are going to go in here. So if I go x equals 42, that is an assignment to x, the value 42. If I go x equals 42, that is a question. Is x right now equivalent to 42? So I'm going to check if number's equal to 15, because that's my birthday. And I'm going to go printf, that's Henry's birthday, \n. I'm working on a Mac machine, but in a Linux virtual environment, which means I meant to Command S to save on my Mac, but Control S to save on the Linux, which is definitely not going to be confusing and bring up an awkward menu every time I try to save. All right. Let's compile. Now our statements, we have these curly braces here. That defines what is inside the if statement. Indentation is not necessary in C, but it's very important to have a good visual idea of what's going on. I've indented the things inside the brackets so that I can visually see that they belong to that if statement. Once it's not indented anymore, or once it's after the brackets, I can see that that's no longer part of that if statement. So I've compiled my code, going to run it. I'm asking, what is your favorite number? I'm going to enter 15. What do we think is going to be outputted? Anything? Nothing? Wow, it sure is. It's Not for a few months, but it is on the 15th. You've learned that so far. So we ask a question. If the answer is yes, we do the stuff inside of that block. We may want to do stuff if the answer is no. If the answer is no, we're going to say else. We're going to say otherwise, we're going to do a different thing. So we can do things if the answer is yes, and we can also do things if the answer is no. So otherwise, I'm going to printf, oh man, maybe a frowny face as well. So I'm saying if the user inputs 15, we're going to print a lovely message. Otherwise, we're going to be sad. So I'm going to enter a number 12, and we're sad about it. So we are asking a question. We are doing something if the question is true, if the answer to the question is yes, and we're doing something else if the answer to the question is no. And by doing this, this is basically how every single computer works. This is how every program works. It just asks a series of yes or no questions, one after the other, and eventually you get Minecraft. Right, so I already went over the else statement. If the answer is no, we can do something else. That's why it's called an else statement. What does this say? We can actually say, we can ask a different question though. We can ask more than one question. We can chain if statements together. We can ask question after question after question after question after question. Apologies. And there's this idea that these chains of if statements are either connected or not connected. So let's consider that. Let's consider if statements that are connected. If I have my first if statement and the answer is no, I can ask a second question. I can say it's going to be else if. I'm going to say, well, what if number is equal to 12? I'm going to print something else. I'm going to print, that's pretty neat. But what if the number is equal to 10? Oh. Then I'm going to print, it's actually 2 in binary. And if the answer is none of the above, I'm going to print f. Not smart enough to come up with anything clever here. So now, every time. Sorry, I thought I heard a question. Was it aimed at me? Or was it a... All right. So I'm asking multiple if statements that are all connected to one another. And I'm saying that if it is the case, then I'm going to do a certain thing. So let's compile my code. Let's run it. Let's enter the number 10. So is the number 10 equal to the number 15? Is it? I want to... No? Is it equal to the number 12? No? Is it equal to the number 10? Yeah? Cool. So what's going to be outputted? It's actually 2 in binary. It's actually 2 in every base. No, it's equal to the base. Anyway. So we can ask questions. We can chain these if statements together. We can have blocks of related if statements. This gets more meaningful when we start asking more than just if things are equal to one another, because there might be some if statements where 2 things could be true, but we care about the order that they happen, and we only want one of them to happen. For example, a number could both be odd and also greater than 15. So maybe we want to do something if the number is odd, but if the number's even and also greater than 15, we want to do something else. So we'll get more entertaining if statements once we learn how to ask cooler questions. How do we ask cooler questions? We're going to use some relational operators. So we have less than, which is for things that are smaller than other things. So you ask if the thing on the left is smaller than the thing on the right. We have greater than, that is the opposite. Hopefully you remember these operations from primary school. Did anyone else you remember the crocodile opens the mouth towards the bigger one? Is that how everyone learned that? Is that a New Zealand thing? I feel like that should be an Australian thing, but maybe it's not. Good to hear. Less than or equal to. So those two symbols next to each other ask the question, is it smaller or equal to? Which could be yes. So 15 is both equal to 15 and also less than or equal to 15. It's both. Things can also be greater than or equal to, they can be equal, and they can be not equal. So the exclamation mark isn't just because we're super excited to be programming, even though we are, it's because it's not equal. All of these will result in 0 if the answer is false, or 1 if the answer is true. And that becomes really handy later on when we're storing variables based on the results of asking questions. That can be quite fun. So let's ask some questions and let's see how else if statements really work. I might make a new file actually. I might touch more if.c and I'll open it. And let's include studio.8 and we'll go int main void. And now I'm going to go, trying to think of something exciting to talk about. I know. The newest season of Australian Survivor begins tonight. I assume we're all excited about this. So we're going to say, I believe we're on to season 13 now. It's called Australian Survivor Redemption, and I assume you're all coming to the Watts party at Zetland Hotel later tonight? That's just me? All right. I forgot to say that it will be an int. Now I'm going to go if actually what I'm going to do is I'm going to say I'm going to make the season equal to 8 because that was heroes versus villains. I'm going to say if the season is greater than 8, I'm going to print that's a new season. \n. However, the season might not only have one condition, might have something else associated to it. If it's greater than 8, I'm going to say it's a new season. If it's even, so what do we think I'm checking if I'm going season mod 2? This is a really common thing you'll do in a lot of your programs. You'll be doing something mod 2. What does that check? Even or odd. So how do I check if it's even? What do I want mod 2 to be equal to? 0. Well done. So I'm going to check if it's equal to 1. I'm going to say that's a pretty odd season. I'm so funny. I'm going to ask another question. The season is equal to 8. I'm going to printf George was robbed. If you've seen Survivor, you'd be laughing at that statement, and if you haven't, this is my class as well. And lastly, I'm going to print, it's a lot of statements. Right, so right now, the season number is 8. Is 8 greater than 8? No, because 8 is 8. Is 8 mod 2 equal to 1? No? Okay. Is 8 equal to 8? Yes? All right. So I'm going to DCC more if minus O prog. Oh, I have an error. What have I forgotten? I've forgotten a semicolon. Now let's do /prog. So we're just going to print George was robbed. But what if I change this to be 9, which, as we all know, was Australian Survivor Titans versus Rebels? I don't know why I felt the need to say that. We all already knew this. Is 9 greater than 8? Yes? Cool. So we're going to print, that's a new season. Is 9 mod 2 equal to 1? Yes. But does it matter? No. Because these else-if statements mean only do this if the stuff above me didn't happen. So because the stuff above has happened, we will only get one thing outputted. So if I change this to be 7, which we all know what that one was, and I run this, what's going to be outputted? Quickly discuss with your neighbor what you think will be outputted. Do it. You have until I finish eating this chomp. I should probably mute myself while I do this. I will not. For some reason, the chocolate that I had was the chocolate that takes the longest to eat. So hopefully you've had plenty of time to understand what's going to happen. What do we think is going to be outputted? Someone be brave, but also pay attention to me again. That's a pretty odd season. We're going to simmer down. I know Survivor's exciting. I know thinking about Australian Survivor Blood versus Water is an exciting thing to do. But we are going to have to lock back in. That's a pretty odd season. Now, okay. Please, I have so many cool things to say. What do you think will happen if I change these from else ifs just to ifs? I just told you to pay attention to me again. Now I'm going to say you can stop doing that. Go back to asking your partners what you think is going to happen now that they're only if statements. Everything's an if statement now. Oh, this if should say something. Change that back to an else. All right, good stuff. Good stuff. What do we think? Now, these if statements are no longer connected to one another. They are completely unrelated and don't depend on each other anymore. So what do we think is going to get outputted? All right, so first we will check if the season is greater than 8, and it's not, so it won't be outputted. Then we check if the season is odd, which it is, so that's a pretty odd season, will be outputted. Then we check if it's 8 exactly, which it isn't. And then because that if statement failed, we go to the else, which will now output. That's a lot of statements. I really need to remember to put my \ns. So we are asking questions, and the difference between an if and an else if is connectivity. If you have else if statements, they must belong to or be grouped with a previous if statement, because the else if statement depends on the previous if statement. Same with else statements. Else statements depend on there being a previous if statement. However, you can just throw if statements together as much as you want, and they can not depend on one another at all. Now, I've only been asking one question at a time because I find it to be pedagogically sound. However, you can ask 2 questions, or more than 2 questions. You can ask a bunch of questions and string them together into one really long and complicated if statement, or else if statement. So you can use 2 ampersands to say and this is the type of and where both things have to be true. So if you said to me, Henry, do you like tea and coffee? And I say no, that could be because either I don't like tea, or maybe I don't like coffee. But because I don't like both of them, because I don't like at least one of them, the answer is no. So the ands, both statements must be true to become true. The or works if either statement is true, or any statement in it is true. So if you said, Henry, do you like tea or coffee? And I said no, then you know for sure I don't like either of them. I don't like either of them. They're gross. But if just one of the statements in the or statement is true, then the result is true. We can also use the exclamation mark to get excited and do not statements, but we won't worry about that right now. It's the opposite of what the expression does. But first, let's do some ands and ors, like my favorite Star Wars show on Disney+. And or. No one liked that joke. That's okay. All right, actually, you know what? I like this bit of code so much, I'm going to leave it in the live code and make a new file. Extra if.c. Include studio.h, int main void, I'll return 0 here. So I'm going to say that I'm going to do an order number. I'm going to say that the order is equal to 66. The Jedi should watch out. And now I'm going to be asking some questions, but more than one. I'm going to say, if the order is greater than 60, and the order divided by 2, mod 2, what am I checking for when I do this line? What am I checking here? Yes, so I'm checking if it's an even number or an odd number, but which one evaluates to true? Even or odd numbers? Odd. Yep, correct. I'm going to printf, the Jedi are safe. C minus O, prog. So I'm asking 2 questions. So first of all, is order greater than 60? Is that the case? Yep. Is the order odd? No? So is anything going to get outputted? No, nothing happens because one of the statements in my ands was false. But if I change this to be an or statement, is the order greater than 60? Yep. Does it matter if the order is odd or even now? Doesn't matter. What did I do wrong here? I didn't save it. And it says the Jedi is safe. So we're asking questions. We're saying if it's an and, every statement must be true. If it's or, one statement may be false, one statement may be true. As long as at least one is true, then it's fine. Now with or, if both statements are true, do we think it's fine or do we think it's not fine? If both statements are true, is that going to evaluate to true? Yeah, who thinks yes? Who thinks no? Who's very sleepy? That's fair enough. So with or, it can be one is true, it can be all is true, it doesn't matter, as long as at least one is true. I can add more statements. I could go or something else, order is less than 5. I can even throw an and in here if I want, but then we get into a bit, you want to be careful chaining these things together. Much like how you can use brackets to say the order in which you want things to happen, you can use brackets to say the order in which you want these to happen. So if I could add, I could change this to be an and I can put brackets here, and I can put brackets here, change that to 70. So when we get to my if statement, what's the first thing that's going to happen? We have some ands and ors getting chained together. The first thing that's going to happen is that we're going to ask if the order is odd or less than 70. Is the order odd or less than 70? Yep, cool. So that comes out to being true. And then it checks, is the order greater than 60? And the previous expression that we talked about evaluates to true. So now, if I run /prog, it prints out that the Jedi are safe. We can also add the not in front to reverse everything. So if I just put bracket here, exclamation mark here, and bracket here, now it's going to reverse everything that's inside here. So let's run it. And the opposite of what I just did is nothing happening, because it's reversed everything inside those brackets. That's what the exclamation mark does. It stands for not. All right, so we now are going to do, Sasha gave us some demo code to do, and I don't have it. That's great. So we're going to ask a question. We're going to do a programming contest. We will do the Kahoot after the break, but we're going to do a programming problem to see how we can approach this problem. So the first thing we want to do is you want to solve the code in our heads. When you see a programming problem, if your first instinct is to start programming, maybe you should think about the problem for a bit first. So we've decided to run a competition to see how many free energy drinks were given out at O Week. Who got a free energy drink at O Week? Who desperately wants a free energy drink right now? Same, except I only drink Diet Coke. Students that guess the right number of free energy drinks win. You get told whether your guess was less than, more than, or the winning guess. All right. So let's touch energy.c, and I'll code energy.c. So the first thing we want to do is we want to get the input from the user. We want to get the number of guesses, and we don't just want to show them a blank screen. So what would be a sensible message to ask the user for their guess? Okay, I'll make up a sensible message, and you can tell me if it's good or not. Print f. Is that a good message for the user?
Yeah.
No? Sort of divided opinions. Can someone give me a better one, please? Shout it out, yep.
Guess how many free energy drinks were given out at O Week for a prize?
Very verbose. Well done. Guess how many free energy drinks were given out at O Week to win a prize. Now I'll need to store this in a variable. I'm going to call it guess because it seems like a good name. I'm now going to scanf in a number, and we're going to put it into the guess variable. What we don't have right now is an answer, because I don't know. But what's a number that we think is a reasonable number of energy drinks that have been given out at a week? 1,000? So someone said 1,000. Someone said 10,000. We have 10,000 students at CSE right now. That's just at CSE. So, yeah, do we reckon maybe like 40,000? Yep, I'll go with 40,000. Although actually, before I do, looking back at the code, it does say if you're within 5 guesses. So maybe within 5, maybe I'll come back down to a less realistic world and pick a 2-digit number, not the one you're thinking of. I'm going to go for 94, even though I think 40,000 is more likely to be the right answer. So now, what does our question want us to do? It says students that guess the right number of energy drinks win. You get told whether your guess was less than, more than, or the winning guess. So I want to know if the guess is the answer. How do I do that? Yep. Hello. Is that your hand asking the question, or is that just? Yes, equals equals. So I just go equals equals, and I'm done. I'm going to go if guess equals equals answer. Then we're going to printf. Congratulations. Now, do we think that I want an elif statement or another if statement? Can someone both win and be close to winning? Or are they sort of exclusive things we don't want them to both happen? Exclusive? So let's do an else if. Else if. We want to say if they're less than. All right, how do I check if guess is less than the answer? The less than sign. If guess is less than answer, I'm going to printf lemao too small. Yeah, that's fine. How do I check if it's now? There's only 3 states we need to worry about, so I could write another else if statement. But do I need to? What could I do instead? I can just use an else statement because there are only 3 states we need to worry about. So I'll go else. I'm going to printf. That guess is too big. Get wrecked. All right. So right before the break, we're going to run this code. DCC energy.c -o prog. I have an error somewhere. I didn't put a semicolon after my print statement. I would like it more if when I do this, everyone screamed at me, and then I would learn quicker. But also you'd get chocolate for doing that. /prog. What's a guess? What should I guess? Someone give me a guess. 2? All right. Damn it. It wasn't 2. But I've tested one case. What's another case that I should maybe test? 94? Yep, it worked there. What's another case that I should guess? What's another case that I should test? 100? All right, I've tested all 3 of my cases. All 3 of them work. My program works. Question there?
What if you wanted to go back and forth with the user without rerun?
Yes, that is what we're going to get to after the break. Great question. Give chocolate because great question. Right now, it is 5 to 12, so we're going to take a quick 10-minute break. After the break, we're going to do a Kahoot. The winner of the Kahoot will get more chocolate. And then we're going to look at loops and how we can run this code over and over again without needing to run it over and over again. Let's reconvene in 10 minutes. When we do Kahoots, there are prizes for the top 3. Sadly, I did not really have much time. So the prize for first place is 3 chocolates. The prize for second place is 2 chocolates. And the prize for third place is a crisp high five. So I guess we're all competing for third. If you are online and you do not receive your prize because you are online, harass Sasha on Monday specifically for the things that I'm not going to give her to give to you. Say to Sasha, I won 3 chocolates, where are they? And if she doesn't give them to you, harass her more. If she does not give you a crisp high five for coming in third, assuming third place is online, demand it. This is not legal advice. This is not actually advice. This is bad advice. All right. I'm going to kick off the Kahoot right now. Oh, just a heads up, in case you're like mentally locked in to think about if statements, this is actually about last week's stuff. Maths. It's a refresher. I've pranked you. Here we go. The beginning. Let's go. Why do we have a main function? Why? Hopefully these questions should be on your device as well, that you should be able to see. Oh my God, that's so many answers. Oh my God. 8 seconds. 2, 1. That's all. Right, so. Okay, Kahoots can get exciting, but if they get too exciting, it's going to be hard to learn. We have a main function so that we have an entry point on execution. When our code starts, it goes into the main function. That is the point. All right, congratulations, Crafty Kangaroo. You are currently winning, but you might not be. What is the syntax used to print hello world in C? It's yellow for a second time. Sorry, I heard someone ask a great question. Is yellow correct? Do you need the double asterisk? The double quotes. I think this still works though. It's the double quotes for when you're storing a variable. Is that correct? My admins who have coded in C more than I have are also looking confused. This doesn't work? Whoops. Sasha wrote this. I didn't write this. I'm throwing her under the bus. Good spotting though. You can have either a chocolate or a crisp high five. For now though, Crafty Kangaroo continues. Oh, whoa. And the crowd goes wild. You can pick more than one. You. Two, one. It's these two. All right. You know what? All right, so in order to do comments, you must have either the double forward slash, which is for single line comments, or with the ones in yellow, you can do multi-line comments. And so your comment goes in between those bits of code. Up 157 places, that's huge. To include the header file with standard C library, put what line at the beginning of each file? Four, three, two, one. Yes, we do hash include stadio.h in the braces. What are they called? There's a name for them. Angle brackets. In the angle brackets. Thank you. Knowing giraffe is living up to the fact that they know things. What does a return 0 usually mean? And why do I never do it? Second part isn't actually. It's so crazy watching that number skyrocket. It's even crazier to think about the fact that we should have 1,000 students in this Kahoot, but it means that the program executed successfully. We put return 0 at the end of our program, and so if we return 0, we can know that the program went all the way through without any errors. Are you two competing? Are you trying to get the crisp high five? That's crazy. All right, fair enough. All right, knowing giraffe continues to know. It's giving hyena. That's a statement. Which of the following declares and initializes an integer variable? Ooh. All right, so a lot of people picked blue, and I understand why you'd pick blue, because you were being tricked. Blue does declare a variable, but to initialize it means you store something there. It's not been initialized yet. Yellow declares it and also initializes it. Red is a constant, and green doesn't do anything. I want to ask the user for an input into my program. What function should I use? I heard someone say fgets. I'm going to get you to leave the classroom. No. It's scanf. It's the one that I showed off a bunch. That's the name. That's what it's called. Social lemur back in the game. What is the correct format for scanning in an integer with an already declared variable named num? It is blue, because we care about the memory address. That's what the ampersand does. It says store it in the variable at that address. That is why you need the ampersand. It's a tight race. It's maths time. All right, time to learn. It's time to learn. Welcome to learning. All right, in C, we have our data types. We have our integers and our doubles and our strings. Now, if you divide an integer by an integer, you will get an integer. So even though the answer is 0.5, it becomes an integer. What is 0.5 as an integer? 0. What's 0 times 500? 0. So this is the thing about types. If this was divided by 2.0, then we would get yellow. But because, in fact, we might even get green, because it would be multiplying a double by an integer. So because we divided an integer by another integer, that is why we get 0. Whoa, whoa, it's a shake-up. Oh, it's a shake-up. Determine the value of the following expression in C. Oh, I just said it. Oh, it's one of the two. We're going to find out if we get a double or an integer. We're going to find out. Is it a double? Is it an int? Is it a double? Or is it an int? It's a double. So this time, we're back to learning zone. This time, we divided by a double. So 1 divided by 2.0, that is allowed to return 0.5. 0.5 times 500 also gets a double, which is why we get 250.0, because it is a double and not an integer. You can divide, so sorry, who asked that question? For the purpose of giving chocolate? I don't know who it was. I assume someone can see you. Oh, there we go. Yeah. So you can divide integers by doubles. You can mix the operations. It just will result in a double. If it's all integers, it becomes integers. If one of them is a double, C converts it to a double for you. All right, question 11, second to last. What is 17 mod 5? Whoa. It is 2. Because when you divide 17 by 5, you get 3 with a remainder of 2. And that's why it's 2. And the final question of the Kahoot, but still so much to quiz for. Determine the value of this expression. Good luck. I'm going to work this out real quick. Oh, God, okay. I reckon I've got it. I reckon I'm the smartest man alive. All right. So let's walk through it step by step. The first step, we have bed mass. What is going on 17 divided by 5? What does that evaluate to? That evaluates to 3, because it's 17 divided by 5, which is 3 point something, 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 something. But because it is an integer, it just rounds down to 3. What is 17 mod 5? 2. So what's 3 times 5? 15 plus 2, 17. Let's see the final results. In third place, we have Champion Iguana. All right, Marvelous Ant in second place. And in first place, we have Knowing Giraffe. Congratulations, everyone. Check, check. If any of you are physically here, come on down right now. Is Champion Iguana here? No? Okay. Is Marvelous Ant here? Also no. Okay. Is Knowing Giraffe here? Yes. All right. Congratulations. I'm going to walk over here. I'm really tall. And then you can also have the high five if you want. Nice. I love my job. If you were second place or third place and online, bug Sasha. It's not my problem anymore. Leave page. All right, so during the break, I went over the coding of the problem, and I realized that there was more steps that Sasha wanted us to do, and I maybe didn't follow them exactly. She may not have wanted us to say Lamau too small, but we have some extensions to do. Within 5, we can say that they're so close, and if they're too high, we can say too high. So now we need to add another if statement. We need to check if they're within 5. How do I check if they are within 5? I'm going to add another elif. I feel like the energy in the room's really come down after that Kahoot. We will do more Kahoots in other lectures. Sasha has a whole lot of them. I want to check if their guess is within 5 of the answer. How can I check that? Funnily enough, using some arithmetic that I've done. I want to check if they're within 5. All right, cool. I'm going to do answer minus guess. Check if that's equal to 5. Now this will work if guess is smaller than answer. Oh yeah, good point. Less than or equal to 5. I can just do the absolute value. That would also work. Now technically, there's another way to do this. If it's less than, oh no, that doesn't work. Yeah, okay, I'm actually going to string a bunch of stuff together. And I'm going to say answer minus guess is greater than or equal to negative 5. Does that still work? Does this math check out? No. We need another one. And, oh yeah, or. That's a good point. A number can't both be, yeah, fair enough. Wait, no, do I need it to be or?
Yeah, because it can't be less than 5 and greater than -5.
I'm not sure I'm convinced. I'm going to go with and here, though. And I'm going to say guess does not equal answer. I'm going to string all 3 of these statements together. So if it's...
But you don't need to do the guess not equals to answer because it's connected with it.
It's a great point. I don't need to do this guess not equal to answer because it's connected to the previous if statement. So now I'm going to printf. It's so close, but no cigar because smoking is bad. \n. Let me compile my pro. What did I forget? Yep. Like my AI generated help. /prog. All right, so what's a number that's within 5 of 94? 89. That's a good one. So close, but no cigar. Perfect, it works. What's another one? Have I tested enough, or is there another scenario I should test? 99. Perfect. And I want to quickly retest 94. That's not how that works. 94 still works. Sometimes when you write code, you think, I've solved it. I'm really smart, and I've added an extra solution. And you don't go and test your old stuff. Then you go and run your old stuff, and you realize you broke something by adding your new code. So I'm just going to double check I haven't done that by mistake. Still works. And still works. Awesome stuff. So now our code, we've gone through the problem, we've broken it into parts, we've asked the student, asked them for a guess, check if the guess is within our bounds, and then check if it's less than or greater than. So do you think the order matters? The order used to not matter. It sort of matters now, I think. Because if I took this code and I put it above this block here, then it would just say Lamau too small, and then not check the maths for whether we were close enough. So the order here does make a difference now. It used to not, but now it does. And that's really important when working with else if statements, because if you get the order wrong, your code can just completely not work. It's really good to think about all of the ways we can break our program, the ways that it can go wrong. We'll deal more with error handling later on in the course, but we should have some error messages that tell us, oh no, you've done the wrong thing. But we're not going to worry about catching errors right now. All right, we've done scanf, we've read it in from the terminal. This talks about how scanf is technically a function that does return something because it returns, what does it say? Oh yeah, it returns an error if there is one, but if you're getting your scanf errors, don't worry about it. So someone asked before the break, I don't want to run my code over and over again. And that's fair. I don't want to either. I don't want to have to recompile and rerun it every single time. So I want to make something happen over and over and over again. Can someone think of a task in real life that they do over and over again, repeatedly? Breathe, I heard someone say. That's true. My breathing is just on a while loop. It just goes forever, usually. Any other tasks that you do? What was that, sorry? Come to the lecture? I hope so. But I hope. I've heard while week is less than 3, attend lecture. I'm not going to say that to Sasha. There's one on the slide I should have talked about. Who here likes music? Yeah, I sort of do. I've been listening to the Jujutsu Kaisen openings currently. They all go pretty hard. And so while there are still bangers in the JJK openings playlist, play some more songs. But when they stop playing songs. I don't want to listen to them anymore. Or maybe go back and play it again, over and over again. Does anyone else just listen to the same song like 30 times in a row until they get sick of it, and then they have a new song? That's my thing of choice. Was that a question, or was that? Yeah, I also listen to the same song over and over and over again. All right, C is executed line by line, starting with the main function. If statements let us go yes or no. And we could repeat the code like this. So I'm going to actually repeat the code real quick. The easiest way I know how. What I'm going to do, I'm going to take this code. First, I'm going to put it answer above, because actually that should go right up the top. I'm going to take this bit of code. I'm going to copy it. I'm going to press enter. I'm going to paste it. All right. Let's run some code. Now I can play the game twice. It's too small. What's bigger? No, I can't play the game twice. Why did it not work? I didn't save. Thank you. $12. And now I can play a second time. OK, but I'm not allowed to play anymore. So what I'm going to do is I'm going to paste some more code in here. All right, now I can play 3 times. Here we go. Now we're getting somewhere. 12 again, 56, 97? Oh, I ran out of guesses. Who wants me to copy and paste a fourth time? Who gets it? Who gets what I'm going for here? Yeah. We could just copy code over and over and over again, or we could programmatically repeat the code a number of times that we want to. Let me get rid of my copy and pastes. We can use while loops, which can be controlled in about 3 different ways. One of them that we'll do right now is called a counting loop. What the counting loop does is it says, while a number is less than a certain number, do your action, and then increase your counter by 1. What this does here is prints forever. So actually, I'm going to put some code. I might break my computer. It's fine. Code while.c. That's not how that works. Oh, it did work. I thought I had to tuts it first. .8 include. Nope. Clearly, I need lunch. While I'm going to go int I equals 5. While I is less than 2. I'm going to go printf yippee \n. All right. And now I'm going to run it. Why not? DCC while.c -o prog. What do we think is going to happen when I run this? Let's see what happens. Oh, I'm so smart. I'm so good at my job. Let's change that to something that will actually enter the wall. I mean, sorry, that was a pedagogy moment. I did that on purpose to test you. You all failed. No. Okay. Oh, my computer's slowing down. Oh, I'm going to kill this terminal. So that was going to go forever. And at a certain point, my computer, or hopefully the virtual machine and not my computer, something would give out. And we'd be in not a great spot. So while loops can be dangerous. Please make sure your while loop will actually exit at some point. Please think about your code before you run it and before you write it. Thank you. What if instead I put I++ here, which is something we can do to add 1 to I, and I'll start I at 0, and we'll go 3. How many times do we think yippee is going to get printed out? Discuss with your neighbor while I cd into my correct directory. All right, I've cd'd into the correct directory. DCC, while.c, -o, prog. All right, who thinks it's going to print out 4 times? 2 times? 3 times? Let's see what happens. It's done it 3 times. Because we get to this while loop, and a while loop is actually just another if statement. So what it's asking is I less than 3? What's the answer? The answer is yes. So now we're going to print yippee, and we're going to add 1 to I. I is now 1. Is I less than 3? I don't know. So is it? Yes. So I'm going to print yippee. I'm going to add 1 to I. I is now 2. Is I less than 3? It is. I'm going to print yippee. I'm going to go I++, so now I is equal to 3. Is I less than 3? 3 is not less than 3, so we're done. The while loop is like, I'm over it. I'm out of here. That is commonly referred to as a counting loop, because we have a loop counter which keeps track of what we're doing and increments after the loop each time. And it says, I want to perform something a specific number of times. Is that a question? What's up?
How important are the spaces?
How important are the spaces?
Yeah, in between like the equal sign and...
Oh, not at all. They don't matter.
We have a style guide. We want them to follow it.
Okay, all right. In terms of the style guide, very important, you should have them. In terms of your code running, there's a contest for the most obfuscated code and the ugliest code. And if I could submit some COMP1511 student code to this contest, I'd be the richest man in the world. No, but C code can look really ugly and work. So that's allowed. Well, it's not allowed in the style guide. Don't do it. All right, so this is a counting loop to keep track of how many guesses we've done. So let's modify our original code to use a counting loop. To do this, I'm going to need a number of guesses. So how many guesses? What's a good name for this variable? Guess count? It's a good name. How many guesses has the user done so far? 0? I've realized no, that's actually, I'm going to put this up the top. Guess count equals 0. How many guesses do we want them to be allowed to do? How many guesses do you think is fair? 5? While guess count is less than 5. Now this is not necessary, but it is for who I am as a person and probably for the style guide. I have to take all of this. I'm going to press the tab button to indent it to make me visually see that it belongs to the while loop. What do I do to make sure I don't get stuck forever? Should I increase guess count? Let's increase guess count. I'll do plus plus. And now I can play my game 5 times. Oh man. This is a real no semicolon kind of day. All right, I'm going to guess 90. Oh, I'm close. I'm going to guess 91. I'm close. I'm going to guess 92. I'm almost done. I'm going to guess 93. I'm going to guess 95. Damn it. But I got 5 guesses, so I can play my game over and over again. I could say that I get 100 guesses. There is one slight problem with this game. I know, only one. That problem is that if I guess 94, it's like, well done, play again. So I guess I'll keep winning. I can't stop winning. I can't stop winning. I stopped winning because the game ended. So that is an example of a counting loop. Another option is we can use a sentinel, which is a loop condition, which assumes how many, with a loop counter, we know how many times we want the loop to run. We want it to run 5 times. With a sentinel value, maybe we don't know the number of repetitions we want to happen, but we know that we want to keep going until something valid happens. A sentinel value is a flag value that tells the loop when to stop. For example, we can keep scanning in numbers until an odd number occurs, or we could keep doing the guessing game until the guess is correct. I played a game in the weekend called Sentinels of the Multiverse that's unrelated. If you were looking at this and thinking it was, don't worry. So let's try a sentinel loop. In this case, I'm going to say, now let me just quickly double check something. This is different than a conditional loop. So with a sentinel loop, I would go is correct and set it equal to 0 because they've not been correct yet. And I'm going to say while is correct is equal to 0. Now I could say while not is correct because a 0 is just false, but I don't want to scare you right now. When do I change is correct? In what scenario do they become correct? The first one? All right, so I'll go is correct equals 1. And I might even enter another printf and go printf goodbye, so that they know that they're leaving. So let's run this one. What have I done? Oh, I didn't actually get rid of my guess count plus plus. So I had a variable, and then I got rid of the variable, and then didn't update my code. Let's save. All right, I'm going to guess 94 immediately. I've done it. The loop's over. But maybe I'm really bad at this game. So I'm going to start with 1, 2, 3, 4, 5, 6, 8, 9. This game's really hard. 15, 30, 4,000. -12, 93. Oh, I've almost done it. 95, 94. Okay, so it will keep going until I get it correct. That is a sentinel variable, where we have a variable that acts as a flag. When we swap it to 1, then we evaluate it true, and the loop ends. Technically, that could be an infinite loop, but only if they're really bad at guessing games. The last option is a conditional loop, which is what I was going to show off before, but this is sentinel loops. So we can ask a question in our loop, such as while, something like while guess is not equal to the answer, keep going over and over again. We still don't know how many repetitions it's going to take. We're not counting how many times it takes, but we are asking, is this condition met yet? So let's try while guess does not equal answer. We will run this one over and over and over again. Here's a fun one. So, I said guess is just a variable. I'll use it at some point. I have not given guess a value, but I'm trying to ask, is this thing with no value equal to something else? And C goes, what the hell kind of question is that? So I need to give guess an initial value. What do we think an initial guess might be? It's just like a placeholder value. What's something that people probably aren't going to guess? -1, 0, both good options. I'm going to go for -1 because I think someone could guess 0 if they were really bad at this. In fact, if I wanted to, I could add another if statement that said, if the guess is negative, I print, what are you doing? But I won't add that. You can extend that yourself for fun. Oh, what have I done? I haven't actually used my isCorrect variable because I don't need it anymore. The cool thing about programming is that I just keep making steps and eventually it works. Keep solving problems as they show up, and eventually you end up with a working program. Maybe 12, nope, too small. Maybe 56, nope, maybe 99, it's close. 95, it's also close. 93, it's going to keep going until the guess is equal to the answer. So I'll run it again. I keep recompiling when I don't need to. 94, we're done. So these are the 3 different kinds of while loops. While loops are tricky, I think. They can be hard to get your head around. There are lots of great examples in the slides for you to run and to play around with. I just did that. But what we learned today is we learned about using if statements to ask questions. We learned about all of the different types of operators. Well, not all of them, but a lot of them. Less than, greater than, equal to, not equal to. We learned to string our questions together with ands or ors. We learned how to use loops and how to loop things around. It says we learned how to do them with a char. We didn't. I'll cover that another time. We learned about chaining if and else statements together. Right. We have about 10 minutes until class is over. If there are any questions that you want to ask and get chocolate thrown at you, you can ask them now. Or if you want more private questions, you can come up. Hello.
What if you put a character in a while loop, like while H?
While H, that's a great question. So With while loops, they can be infinite. If I just say, so they've asked a really good question. One evaluates to true. So if I go while 1, that's going to go forever. If I go while 8, let's find out. Nope. It will also go forever. The reason for that is that 8 evaluates to some number, and any number that's not 0 is true. Great question. Throw at him. Okay. People are getting a bit rowdy, so I'll still throw chocolate at you, but what's your question? Feel free to come up. What was that, sorry? C does have for loops. We'll learn about them next class.